and we need to integrate them. So the first one says find the integral of x cos x dx. Well, you can't use u substitution in this case because none of us will give the other one, which we can cancel out. So in this case, we're going to use integration by parts. And if you recall the formula for integration by parts, it's u dv equal to u v minus the integral of v du. You must be able to recall that one. So from here, we need to pick the part. Remember, it's a product of x and cos x. So we pick which one we are going to can easily be differentiated. Well, x can easily be differentiated, and because you've picked as x which can easily be differentiated, that will be our u. So our u will be equal to what? X. Since our u is equal to x, then we can find du dx. So du dx will just be equal to 1. Right? That means whatever that has remained in that first part is our dx, or in short is our dv. So our dv will remain to be cos x dx. Now, since remember we need to find v, so v is just the integral of this one, by the way. So we just have to integrate cos x dx. That's how you find the v. Now, what's the integral of cos x? Well, it's just an x, right? Yeah. It's an x. Now that we've got all the information that we need to plug into that equation, we are going to have the integral of u is just x, then dv is just cos x, like the original from there. Then dx equal to, what is u? U is x. Then what is v? V is sine x. Minus the integral of, what is v? V is sine x. What is du? Du is just 1 dx. But there's dx here. So dx. So this will give us the integral of x cos x dx equals to x sine of x. Now, minus, what is the, well, now we need to integrate this part. What's the integral of sine x? That is negative cos what? X. So the final answer, we can put plus c. Therefore, the final answer becomes x, the cosine of x dx equal to x sine what? X plus cos x plus c. And that's the integral. That's the integration of that one. Problem number 2 says integrate 2x e to the power x. Well, which one can easily be differentiated is 2x. So that will be our u. So our u here is 2x. And we are going to find what? Du dx. Du dx, which will give us what? Which will give us 2. Therefore, we can just say du is equal to 2 to dx. Okay, so let me just take you back here. You can do this. Yeah, there was no need to repeat 2 of them. So du is equal to 2 dx, right? Then we need to find, now that we've got this one here and we've got this one here, okay, we need to look for dv, right? dv dx. So dv dx is what has remained, which is e to the power x, right? So in short, v, okay, is just the integral of this one, or the integral of e to the power a, anything, or let's say to a power a single digit, a number like x, a, or 2, just the same one. So this is just e to the power x, that is v. All right, so we have number 3 here, and we have number 4. Everything is there now. We can now integrate the integral of 2x e to the power x dx equals, what is u? U is 2x. What is v? V is e to the power x minus the integral of, well, what is v? V is e to the power e. You're multiplying by what? Du. Du is here. Du is 2 dx. Okay, and proceed and say this will be 2x e to the power x dx, giving us 2x e to the power x minus the integral of 2 e to the power x. We just multiply those two, and we can conclude and say that this will give us 2x, then e to the power x. Remember, the integral of 2 e to the power x is just 2 e to the power x plus c. Done. The next one says find derivative of x ln x. Now, whenever you have a natural logarithm like ln of something, you take u to be the natural logarithm. So in this case, our u would be the natural logarithm of x, and we can find our du to be 1 over x. You know this property, then dx. Then whatever has remained, it will be our dv. So whatever that has remained, in this case, our dv will be equal to what? X dx. Then we integrate this one to get v, which just gives us x squared, you divide by 2, right? We have all the parts that we need to integrate this equation, this sort of function, and we follow that. To be x, the ln x dx equal to what is u and what is v. So that will be ln x multiplied by x squared, we divide by 2, minus the integral of what? Of v, which is x squared over 2 multiplied by du. Okay, du is just 1 over x dx. We continue. So the integral of x, the ln of x dx, will be equal to x squared, all right, over 2. Then you have ln x here minus the integral. Well, here you would see that this one cancels there, right? So that we've got the integral of what? X over 2. Then what? dx. And what we get here? We have x squared over 2 ln what? Ln x minus. This can now be integrated, and once we integrate this one, remember the power will drop down after increase it. That would be x squared over 4. Okay, there's already 2, another 2 come down to give us what? To give us a 4 there, which can now be simplified to, I love to leave my work in this form, if you don't mind. This will just be half x squared ln x minus 1/4 of x squared plus 4 plus c, sorry. Well, at least we've learned something.